This last problem is great because it is very abstract. So we are supposed to find the sum of all base 10 integers such that both their base 5 representation has 4 digits and their base 2 representation has 7 digits. Okay, so there's a couple pieces of wisdom I want to share with you in this problem before we get started. So, first of all, the greatest value in any base is when all of the digits are equal to the greatest value. So, for example, if I was doing base 10, 99 is the greatest two-digit number. And we can essentially use this rule that the greatest n-digit value is going to be the base times n minus 1. Okay, so that's why right here for the greatest two-digit number would be 10 squared minus 1, or 99. And that rule applies in every single number system. Okay, so now that we've got that in mind, because we're trying to find this, the sum of all the values that make this happen, we want to think about our bounds, okay? And with our bounds, we know what the largest value and the smallest value is with those n digits in that base. And then we want to see what values are going to fall within those bounds. Okay, so sorry if that wasn't really clear. Let's try to break this down by the specific number. So if I'm talking about base 5, then the greatest value, the greatest 4-digit base 5 value is going to be 5 to the 4th minus 1, or 624. Now, the smallest 4-digit value is going to be when we have a 1 in the greatest place and then zeros elsewhere. All right, and this is essentially equal to 5 to the 3rd. So when I have a value that has n digits, the greatest value is going to be 5 to the n minus 1, and the smallest value is going to be 5 to the n minus 1. So that's like a general rule that will work for you. Now, when I'm looking at base 2, if I apply that same rule, then my max is going to be equal to, and again, I had 7 digits here, is going to be equal to 2 to the 7 minus 1, which is 127, and my min is going to be equal to 2 to the 6, which is going to equal 64. So essentially here, we have our range of values. So with my base 5, my number is going to be between 125 and 624. So if I were to look at a number line here, and I were to say 125 is right here and 624 is right here, I would say that these values, we'll go with yellow, are in here, okay? And that's for my base 5. Now my base 2, on the other hand, is between 64 and 127. So 64 is way over here, 127 is right here, and we're about to do some pretty artwork. Hope you're ready. Oh, look at that lovely overlap. And so that right there, that's where my winning section is. So 125 to 127. Those are the only values that fulfill this criteria. And so we just say 125 plus 126 plus 127, and that gives us 378. So again, the big takeaway from this problem is when we are given any number, okay, and in this case it was base 5 and base 2, and we have a specific number of digits, so n digits, the greatest value is 5 to the n minus 1, and the smallest value will be 5 to the power of n minus 1. All right, that's it.